radiochemistry at the Moscow Lomonosov University. An undertaking like this is in no way an everyday occurrence for the scientist. Koppensteiner is a layman after all, and the experiment is anything but ordinary. Yuri Sapochnikov, head of the Venerable Institute, has left himself plenty of time and instructed several of his young students to apply themselves to the problem.
When I told him about experiments that had been carried out in other institutes, he really said, no, this is not possible. But he told me, I've been doing, research work, with radiochemistry now for almost 40 years. I have never heard, that something could reduce radioactivity. So somehow, I think it was, the personal sympathy we felt for each other. He said, okay, give it a try.
The result of the test is just as most physicists would have expected. No reaction. Contrary to similar tests, the radioactive rays in the bottles have not diminished. Was the test too absurd? Did Koppensteiner expect a miracle?
Miracle, for me, is something, that happens beyond our understanding. That doesn't mean that it's in reality a miracle. Miracles always have, reasons. There's always a cause for the effect. Miracles are just an indication that we do not understand all. From a broader perspective, most likely, miracles are something, quite normal and just belonging to some other laws and conditions.
Some people will begin to think that our research borders on fraud, I'm afraid. But the time will soon come in which new parameters are introduced. Then everything will be in place, and scientists will be able to check our findings and also the relevant technology. Investigating the inner order of water, its memory, and the influence of the heavens, one inevitably comes across the quintessential myth, the snowflake. Do these artworks of nature store information in their bizarre forms? Do they bring messages from heaven to earth? Each year, sextillions of snowflakes fall from the clouds, and each crystal is unique. For centuries, researchers and philosophers alike have been fascinated. The first to photograph snowflakes was Wilson Bentley, a farmer from Vermont. Bentley became an obsessed photographer at the end of the 19th century because, as a child, he had heard a sentence that he couldn't forget. No one snowflake is like another. The Center for Snowflake Research is today in California, of all places, at the California Institute of Technology, where there's a physicist who searches for the order that governs the wondrous forms of snowflakes. Ken Librecht is currently the sole physicist able to produce snow crystals in a laboratory. All thought of cosmic energy is scoffed at in these rooms. Ken works quite arbitrarily and always somewhat casually.
Oh gosh, it just sort of came up one day. We were talking about science and things in general, having a beer, and with some students, and it came up, and I was basically just interested enough to start researching it, just to learn about it, and then I got very interested in it. I found the physics was interesting, and a lot of it was unknown, and it looked like one could learn a thing or two by doing some experiments.
The snow crystals are bred in an icebox. It soon became clear that they react to the tiniest differences in temperature and to particles of dust in the air too, and that they alter their shape accordingly. Librecht won't own to having noticed any memory or cosmic influences. Thus, the old question as to whether two flakes look alike answers itself in a profane way.
Well, similar shape you can find, it's sort of true that no two snow crystals that are alike, at least the complex ones that fall out of the sky, they're a little like people. They have a lot of little nooks and crannies, and the shape they're in depends on the path they've chosen to fall through the sky. And no two crystals take exactly the same path, and so no two crystals are exactly alike. They're like people.
So it's that simple. But what is the solution to the great puzzle? Will the whole excitement about the memory of water turn out to be a delusion in the end? Or will the laws of physics have to be rewritten? Both supporters and adversaries alike of these daring theses profess to possess clear-cut evidence and claim to have true science on their side. One might accuse these courageous discoverers and inventors throughout the world of boundless naivety, they who are not afraid to question nature's laws. But in its infinite and glorious variety, water itself points physicists and heretics alike down a common road. A road with a signpost. Never give up. I'm quite sure that we're on the right track. When I started to work with Yuri, I sensed that it was right. I'd like to add that lots of people come to us who've worked out new technologies, who busy themselves with the physical effects of water. They come to us because they're turned away by traditional science, which is often afraid of them. However, fear is something that hampers the development of science. We investigate these claims and phenomena according to strict scientific laws. If we find conformities which can be proved beyond doubt, we don't hesitate to talk about them and inform the general public.
Sometimes persistence does pay off. If you have a scientific instinct that tells you that people are ignoring something, I think it would be quite wrong for me to say they shouldn't pursue it. Because going against the common belief is a very exciting thing to do in science and can lead to dramatic new discoveries.
The
scientists call it H2O, and that's it. That's the end of it. But there's a lot more to it than that. And I'm of the opinion that they should look into water more.
Kümmern sollten.